doing? I hope everyone is doing great. Yeah. Today I'm going to continue our lesson on trigonometry. Okay. So far let's recap what have we learned. We have learned Pythagoras theorem. We have learned trigo ratios. Right. Those were in Sec 2. So what were they useful? They were useful to help us find the length of right angle triangles, or using trigo ratio to find angles and length of right angle triangles. Those are what we learned in Sec 2. But what if the triangle is not right angle? That's why in Sec 3 we learned sine rule, right? So today we are learning something else. So more than sine rule, we're going to learn the cosine rule, right? How can we use cosine rule to find the length or even angles of a triangle, whether it be right angle or non-right angle, right? How can we use the cosine rule? So I'm going to share with you now the proof of the cosine rule, so you learn where it comes from. Alright, so I need everyone to pay attention, right? Pay attention. Everyone, eyes on me. I can see you. Yasu, are you with me? Olivia, are you with me? Melody, are you with me? Good job. Crystal, there? Yes, excellent. Okay, come, let's take a look. Over here we have a triangle. It's a non-right angle triangle, right? Just random triangle that I drew. I let this point be A, this point be B, this point is big C, right? So this triangle ABC, normally we denote the vertices using capital letters, big A, big B, big C. Normally we denote, okay, again by convention, we denote the length opposite the point to be the small alphabet. So if this big A, this side will be little a. If this big B, opposite will be little b. Big C, opposite side will be little c. Okay, so now if I were to just drop a vertical line from point A, such that it's perpendicular to the line BC. Okay, such that it's perpendicular. I call this point T. Okay, let's call this point T. And then for this length of CT, I let this length be X. Okay, if this length is X, since this entire length is A, right, little a, if this is X, I'm right to say that this length here must be A minus X. Yeah, A minus X. Okay, now I want you to pay careful attention to this triangle CAT. Okay, triangle CAT. Okay, let's see what happens. Over here, AT. Oh yeah, the height of a triangle. Just now I said I drop a vertical line now, right? I let this length be H. Since it's a vertical height, so I let it be H. Okay, so now you look carefully at this triangle CAT. You realize the right angle triangle. If it's a right angle triangle, that means Pythagoras theorem can apply, right? Means x squared plus h squared equals to b squared, right? Because that's what the Pythagoras theorem states. The square of the hypo is equals to the sum of squares of the other two sides. So this tells us that x squared plus h squared must be equals to b squared. So I can rearrange it such that h squared is equals to b squared minus x squared. Okay, so for now I'll just stop here first. Alright? I want you to pay attention to another right angle triangle. Triangle BAT. Triangle BAT. Let's take a look at triangle BAT. Hey, it is also a right angle triangle. So that means the Pythagoras theorem will also apply. Okay, it means that h squared plus a minus x bracket square must be equal to c squared. Am I correct? See, h squared plus a minus x bracket square must be equal to c squared. Because this is what the Pythagoras theorem states. The square of the hypo is equal to the sum of squares of the other two sides. So if I rearrange this again, I make h squared the symbol of the formula. So c squared minus a minus x bracket square. So this is my equation 2, right? Wait a minute, h squared equals to this, b squared minus x squared. H squared is also equals to c squared minus a minus x bracket square. What can we do? That means we can equate them, right? So let's say I substitute 1 into 2. Let's see what we have, alright? So we have b squared minus x squared equals to c squared minus a minus x bracket square. So we can just expand and simplify this part, right? So b squared minus x squared equals to this c squared, and then over here you expand. Be very careful, there's a negative sign here. So expand this part is a squared times minus 1 will be minus a squared. So this is negative 2ax. So times minus becomes plus 2ax. Negative x times negative x is positive x squared times minus becomes minus x squared. So over here we take a look. The negative x squared and the negative x squared, we can remove it easily. They'll cancel off itself when we add x squared to both sides of the equation, right? The negative x squared and the negative x squared will just be removed. So what I have now is I have b squared from here, right? So I have b squared equals to c squared minus a squared plus 2ax. So far so good? Are you with me? Okay, now we have one more thing that we need to manage. Oh yeah, we have x here. What can we do? Let's take a look at this triangle CAT again. Let's look at triangle CAT, okay? In triangle CAT, do you notice that if I were to take the cosine of angle C, the cosine of this angle C, what happens? Cosine angle C equals to adjacent over hypo, right? So the adjacent is x, right? The hypo is b, right? Opposite is h. So cosine is equal to adjacent over hypo. So it's little x over b. Little x over b. So if I rewrite this again, that tells me that x must be equal to little b cosine angle C. So far so good? That means I can substitute this. Let's say I call this equation 3. Okay? I can sub this. Okay, tell you what, I should call this, maybe I should call this equation 3 instead. Then I call this equation 4. Okay? Basically, all I'm trying to do is I'm just trying to substitute this into this. Okay, I'm trying to substitute what is x. X is b cosine angle C into equation 3 to replace my x with that. So what do I have? I have b squared equals to c squared minus a squared plus 2a. Instead of writing x, Mr. Ng will write b cosine angle C. So far so good. So if Mr. Ng tidy this up again, okay, I bring the negative a squared to the left, I bring this to the left, I end up with c squared equals to something, right? So this will be c squared equals to, okay, so watch here, if I leave c squared over here, so I have b squared on this side, I bring the a squared over to this side, I have a squared plus b squared, then I bring the positive 2ab cosine angle C to the other side, become minus 2ab cosine angle C. So, my dear girls, this is what we call the cosine rule. Okay, the cosine rule. So what does the cosine rule state? Okay, the formula is c squared equals to a squared plus b squared minus 2ab cosine angle C. Some of the girls tell me, Mr. Wow, so hard to remember this formula, so hard to remember. But if you look closely at it, right, do you see that this c squared equals a squared plus b squared looks a bit familiar? It looks like the Pythagoras theorem, right? C squared equals a squared, so you just have to remember after you minus 2ab cosine angle C. Okay? So again, the second question I have is some girls will ask me, Mr. Ng, but I cannot remember which one is A, which one is B, which one is C, how to remember? Okay, this is how I remember it. Let's say I have a triangle. Okay, I have a triangle. So I use the same triangle. This is A, this is B, this is C. So this is little c, this is little a, this is little b. So when I want to try to find the unknown over here, right, what I need to have is I must have the little a, the little b, and the angle, the sandwiched angle. If you look carefully at this, doesn't this look like the sandwich thing that we learned when we were doing the area of a triangle? Half A, B sine C. Can you remember? The bread, and the patty. Right? So this is very much like that formula. Right? Something like it. So C square equals to the bread square, the bread square, the bread. Remember the bread square, minus 2AB cosine angle C, which is the sandwiched angle. Okay, so for me, when I want to apply the cosine rule, so I always look for the bread and the patty. So if I have one bread, I have another bread, I have the patty, that means I surely can find the opposite side. I can find what is C using the cosine rule. Okay, so far so good.